From medical implants to aircraft engine parts, 3D printing is defining the next industrial revolution. Infraprint's technology, which was developed in UCD, enables the 3D printing of engineering plastics stronger than any system on the market, empowering companies to manufacture high-strength, lightweight, customized parts in a cost and time-efficient way. Please welcome from Infraprint, Andrew Dixon.
Thank you, Anton. Hello, everyone. So before I go into Infraprint's 3D printing technologies, I first want to talk about a problem in the industry with making polymer or plastic parts. So today, the majority of plastic parts are made using a technology known as injection molding. This is a very simple process where we take a metal mold, inject a melted polymer, allow it to cool, and presto, your part pops out. Now, this is a really good technology because we can make thousands or even millions of parts really, really quickly. But when it comes to making small quantities of parts, say 5, 50, or even 500 parts, it can be extremely expensive because these molds can cost 50,000 to 500,000 euro, depending on how complicated they are. So there's a technology we use to replace this in a lot of different sectors, and that's 3D printing. 3D printing is a wonderful technology in that we can make one part or 100 parts, and they'll all cost the same amount because we don't need to make these really expensive metal molds. So the only downside of 3D printing is that the parts typically are about half the strength of the part that you would get from a molding process. So if you're putting it into an aircraft, you're not going to be too happy if it fails when it can't stand up to the stress. So I hear you say, why isn't there a solution that can combine the benefits of both of these technologies in one? And this is exactly what Infraprint's technology has achieved. So Infraprint has developed the Solaris 3D printer, which harnesses the power of the sun in the form of infrared light and heating to produce the strongest 3D printed parts that are currently possible in the industry. We have performed a number of trials from aerospace and energy to medical devices and many, many more to provide superior quality parts in very low volume to our customers and partners. Going into 2023, we are looking to begin a beta program for our new system for the Solaris 1, which is a desktop-sized system which can be fitted into your lab or even on a desk and allow you to produce these incredibly high-strength components without the need for very high capital investment. So if you have an interest or a potential need for high-strength polymer parts for your company, then I'd hope that you would contact me or look to infraprint.com to see further information. Thank you very much.
Thank you, Andrew. Come on over and grab a seat. Can I start with your last sentence? If you have a desire for high-strength printed polymer products for your company, that sort of Venn diagram between companies that need high-strength components but don't need them in large quantities, who lives in that crossover? Who are the market?
The majority of the market would be between aerospace and medical devices, particularly in med device where individualized components are becoming a very or an increased theme now in the industry. So rather than making a one-size-fits-all, like shoe sizes, small, medium, large, we would take a scan of an individual person, maybe a CT scan, and you will have a part made just for you. So we only make that part once.
And is strength in those components a critical factor?
It would depend on the application, but what we see is whether it's a hip implant or cranial implant or an aerospace component where there's only maybe 5 in the one aircraft, that strength is absolutely critical.
And your sale then, I take it, is you sell the printer rather than selling end product, or do you license, or have you worked any of that out?
So we have a physical printer that we sell as our end-use product. The system itself is also significantly smaller and lower cost than what's currently available as an industrial system. Most 3D printers on the market that are industrial would be about the size of a small hatchback. Our system can sit on a desk and produce parts that are about twice the strength of those machines.
It strikes me there must be industrial giants who make these hatchback-size printers. What's to stop them doing the same thing? What have you managed to find that they haven't?
So we patented our infrared heating technology, which is what gives us the key to our success. So it really is protected through the university, and it's also has a control system behind that that enables the superior strength. So it's not just a case of, oh, look, here's a heater, we can plug that in. It actually has intelligence behind it that controls how the heating is applied.
And briefly, do you think the ultimate aim is that one of those large industrial companies might seek to take you out of the market a few years down the track?
I think we're aiming at the moment to become a sustainable company in our own right, but if that does come down the line, then you never know.
Andrew, thank you. Stay there for a second.